Hi there folks, I thought I'd give you a lesson in my classroom seeing as though I'm in school today and I thought it was a good opportunity for me to use the whiteboard and you could see my ugly face again. Okay, so I'm going to give you a lesson today on what we call finding the nth term formula. And before we do that, I'm just going to give you a quick recap of how we generate a sequence using a formula. So on the board, I've got my formula. So this was the notation that you met on your previous lesson. So Tn just stands for term number. And this formula says 2n add 3, which means you're doubling the number and then you're adding 3 to generate the sequence. So the first number is 1, so that's the first term. So we've put T1 for our first calculation. And T1 would just be 2 times 1, add 3, which I make that to be 5. So that means the first number in our sequence is 5. Okay, now if you want to start skipping these lines because you're feeling very confident in using a formula, that's fine, but that's just showing the calculation that arrives at the first term in your sequence. T2 then, so this says 2 lots of 2 this time because n is 2. So 2 times 2, and then add 3, and that makes 7. So the second term in our sequence is 7. Okay, and the next term then is the third term, so t equals 3, so 2 times 3, add 3, and that makes 6, add 3, which makes 9. So our third term in our sequence is 9. And our fourth term, so 4's going into our formula, 2 times 4, add 3, which makes 11. So our fourth term is 11. Okay? And so this is our sequence that is generated by this formula. So 5, 7, 9, 11. You could probably guess the next number, 13, and 15, and 17. And that idea of looking at patterns is really, really important when you're trying to find a formula. So we're going to work in reverse now. We're going to work out how we get from a sequence like this to the formula like this. And the way in which we do it is we use a little quirky acronym that I've come up with, DINO, okay? And I'll tell you what DINO means in a minute, but let's just have a look at breaking down our formula that we've just used to generate this. Now, each step between each of the terms is going up in 2's. Now, there's no coincidence that what we multiplied n by was also 2. That's an obvious link, okay? Because the sequence 2n is like the 2 times table. It's going up in 2's. So our sequence is also going up in 2's, so it's got to be linked to 2n in some way. But the plus 3, that was just kind of like an adjustment that we make in order to not start the sequence at 2, which is what the sequence 2n starts at, 2, 4, 6, 8, 10 and so on. It starts at 5, so we had to add 3 to it before we get to that first term in our sequence. Right, so here's my funky dinosaur. I'm a dreadful drawer. Mrs. Kilkenny will do a much better drawing, I'm sure, in her notes for you. This is what DINO stands for, though. DINO is really, really useful. It stands for difference in number. So the difference in number in your sequence is linked to that n. And then the O actually stands for the 0 term. And I'm going to show you how to use DINO, because DINO is awesome. It's such a clever way of finding a formula. So I've got 2 examples, which I want everybody to try and do and follow. And then I've got a challenge for those of you who are going to zoom on and try the extension work for today. But we're mainly focusing on the increasing sequences. So looking at this sequence then, you can see 7, 10, 13 and 16. This is going up in 3's each time. So it's going up in 3's, so it must be linked to the sequence 3n. Okay, so whatever that jump is the multiple of n in the sequence. This was going up in 2's, so it was linked to 2n. This sequence is going up in 3's, so it's linked to 3n. Okay, now the 0 term, what I always do is I always kind of put a blob in here and say, well, this was the first term of our sequence, which was 7. Then we added on 3 to get to 10, added on 3 to get to 13, added on 3 to get to 16. If I was to take a step backwards to get the 0 term, then I'd have to take 3 off. And if I take 3 off the 7, that gives me 4. So the 0 term is 4. And now if I bring these two things together, we just say in that posh formula way, The term number, the formula, is 3n, it's the step, and it's also the zero term. So it's 3n plus 4, and that is our formula. Okay, so you look for the step, and that's the multiple of n, the difference in number, and the zero term is the bit you're going to add or subtract on the end. Right, let's try this one then, a super hard one. So this sequence is 11, 15, 19, 23. So again, if we look at what this sequence goes up in, it goes up in 4s each time. So it's a step of 4. So because it's a step of 4, that means it must be linked to the 4 times table, or 4n. Okay, so that's part of our formula. Our zero term, put your blob in. And again, you were taking a step up of 4 each time. So from the first term, we added on 4 to get to the second term, added on 4 again, added on 4 again. If you want to go backwards, take a step backwards, that's minus 4, and that leaves you at 7. Now this number could be negative. If you take a step back bigger, it could be negative, which would mean you'd have to subtract in your formula. But again, we've got another positive number. So if we bring these two things together, we've got our term number is the 4n bit and the plus 7. And there's our beautiful formula for our sequence. If you can do them in year 7, that is amazing, absolutely amazing. Okay, but I know some of you won't be satisfied with that. You'll want to try even harder ones, and you want to look at what happens when I've got a decrease in sequence. So I'm just going to talk you through this, but for most of you, I want you to stop there and just master that skill, because that would be fabulous. So I'm just going to carry on and look at this challenge now. Now this sequence, instead of going up, is going down. So I'm taking 2 off each time. So because I'm taking 2 off, rather than adding 2 on, it's going to be linked to minus 2n. Okay, oops, put my blob in the wrong place, sorry. It's going to be linked to minus 2n because it's a sequence going down, and that negative is what causes the sequence to be reducing each time. And again, I've got to be super careful here. To do the zero term, if I was going down in 2s each time, to take a step backwards, I've got to do the opposite. So because I was going down in 2s, I've got to add 2 on to my first term. And if I add 2 on, that gives me 13. So my formula for this super hard one is going to be minus 2n add 13. Some people like to write it the other way round. You might see it as 13 minus 2n. It actually means exactly the same thing. If you like to start with a positive term and then take bits off, that's fine. If you like to just always write the nth term bit at the beginning, that's also fine. Okay? And that is our